does show you is up at the top. It does give you guys a video, and that video of different alkali metals, so sodium, potassium, that group 1 on the periodic table, and it shows how they react with water. And you should see that as you keep going down the periodic table, it does get more violent as we go down and makes larger explosions when you put parts of sodium, potassium, and all those other alkali metals in water. So the first thing that this formative is about what makes those alkali metals so reactive. So you should be including those vocab terms, so valence electrons, reactivity, ionization energy, and octet rule. So something that I was looking for here would have been about how the alkali metals have one valence electron. So each of those metals have one valence electron, which means they've gained a new orbital, making them larger, making their ionization energy smaller because they have their electron farther from the nucleus, which means less attraction between those protons and electrons, making it want to react more because it wants to fill that octet rule, stating that it wants 8 valence electrons. So it's more reactive because it wants to get rid of that one valence electron. So I'm not going to write all of that out, but if you included those 4 terms in some way, explaining how it has one valence electron and how its ionization energy is going to be larger due to that smaller Coulombic attraction, or sorry, the ionization energy is going to be weaker because it has a small attraction between its protons and electrons, because its protons and electrons are farther away from one another. And then that octet rule stating that every element wants to have 8 valence electrons. The alkali metals are going to only have to lose 1 valence electron to fill that rule, which makes them more reactive, which makes them super reactive, which is why they're going to explode with water, because they're going to be quick to lose that 1 valence electron. There are questions on that one? All right, so then number 2 says we wanted to draw the ions here. So I'm going to draw the actual elements Lewis dot structure. So argon has 8 valence electrons, and it's a noble gas, which we should remember that noble gases do not react. So there's no ions created. So there's no ion for this one because it's a noble gas, or because it does not want to gain or lose any valence electrons. It already has its 8. It doesn't want any more. It doesn't want any less. So it does not create an ion because we only create ions to fill out our 8 valence electrons. The next one is arsenic, so As, which has 5 valence electrons. And arsenic doesn't have 8, and it's easier for it to gain 3 electrons than it would be to try and get rid of 5 electrons, which means arsenic is going to get 8 valence electrons in the end. And when it gets its 8 valence electrons, it's going to have a -3 charge, because that -3 tells us we have gained 3 electrons. The next one was aluminum, and aluminum has 3 valence electrons. And since it wants 8 valence electrons on its outermost orbital, it's going to lose these 3 valence electrons, so it can have 8 valence electrons on its outer orbital. And when it loses those 3 valence electrons, it shows 0, even though now it lost that outer ring and now has a full inner ring. So it has a +3 charge, saying that we lost 3 electrons to have our full 8 valence shell. The next one is beryllium, and beryllium is just like aluminum, except for it has 2 valence electrons. And because 2 is easier to lose than it is to gain 6, we're going to lose these 2. And beryllium will have a +2 charge because it lost 2 valence electrons. Boron has 3 valence electrons. And again, 3 is going to be easier to lose than it is to gain 5, which means we're going to lose these 3 right here. They're going to go away. And we're going to be left with boron having a +3 charge, as it lost 3 electrons. Bromine has 7 valence electrons. And it's going to be easier to gain 1 than it is to try and lose 7 valence electrons. So that bromine is going to then end up with 8 valence electrons, which means it gained 1 electron or gained a -1 charge. And then last but not least, we have carbon. And carbon's going to do either or because it can gain 4, it could lose 4. So it depends on what it's going to bond with. So we can either draw carbon, which had lost 4 electrons, so it has an inner shell that's full, or carbon's gained 4 electrons and now has an outer shell of 8 valence electrons and it has a -4 charge. So this one can go either way here. Are there any questions on our ions and how they were created? All right, so then the next one says, what determines the type of ion an element will form? So if we look back up above, it gets determined by the gaining or losing of electrons. So gaining or losing electrons determines its ion or the type of ion we create. So it depends. So it's going to depend on whether the element gains or loses its electrons. Then last but not least, aluminum and tin are metals commonly found in their pure elemental form in everyday life. Why are these metals allowed to exist in their pure form, but metals like sodium are not? So for this one, I was looking for you guys to explain something along the lines of sodium has 1 valence electron, meaning it reacts quickly. To get rid of its valence electron to have a full outer shell. Aluminum has 3 valence electrons. And tin has 4 valence electrons. Making them less reactive. Because they have more valence electrons to lose. Are there any questions on 3 or 4 or on anything from this formative? All right, then what you guys are going to be doing is The rest of the day today is working on this review. So you have, I believe it's 10, nope, 12 multiple choice questions identifying ionization energies or electronegativities, atomic radius, reactivity, Coulombic attraction, identifying which one has the largest or smallest of each of those trends. And then below, you guys have 7 questions about the explanation aspect of it. So explaining those trends and why they exist. So if we look at something like question 17, it says explain what causes ionization energy to increase going across the periodic table. Make sure you're not just saying it increases because the ionization energy gets bigger. Make sure you're explaining about the Coulombic attraction, or that attraction between the protons and the electrons, and how that attraction will affect the ionization energy. And explain how the other trends play into the ionization energy, atomic radius, Coulombic attraction, electronegativity. All of them play into one another. So make sure you're explaining not just because it gets bigger, but give me that why would it get bigger? What causes that ionization energy to increase? What causes that electronegativity to increase? Not just it increases because it's getting bigger. Do you guys have any questions about what